Lesson 5.6, Inverse of a Function. Our essential question. How do you find and verify the inverse of a nonlinear function? So there are 3 problems left on the page. Let's go ahead and do these for independent practice. I have my f of x rule. I'm supposed to find the inverse of it. I currently can't because it needs to be written as a y equals problem first. So instead of f of x, I'm going to write y. So it's now a y equals problem. But to find the inverse, I am supposed to switch my x's with my y's. So instead of a y, I'm going to write an x. Instead of the x, I'm going to write the y. Now to actually make this inverse graphable, I need to solve for y. So I'm going to add 2 to each side. This is an x plus 2 equaling a 1/3 y. I'm going to multiply both sides by the 3. So I have a 3x plus 6 equaling y. But if it's the inverse, we call it g of x. So this is g of x equaling 3x plus 6. I am now supposed to graph both of them. And when you graph them, you are supposed to observe that they do in fact reflect across this y equals x diagonal line. So graphing f first. The y-intercept is a -2. The slope told me to go up 1 over 1, 2, 3. Up 1 over 1, 2, 3. Up 1 over 1, 2, 3. And you do that till you run out of graph paper. So this is my f of x line. And I need to graph my inverse. The y-intercept is 6. 1, 2, 3, 4, 5, 6. And slope is up 1, 2, 3 over 1. I ran out of space. So we're going to go backwards. 1, 2, 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. I have enough room to actually connect. Here's me connecting my line. And this is my g of x. The reflection line, if you were to fold the paper right across that line, you would see that these would line up. So we know that we graph the inverse accurately. So we have an f of x that we are being asked to find the inverse on. I can't find the inverse because currently my f of x needs to be written as a y, so I could do it. Instead of f of x equals, I'm going to rewrite it as a y equals. Now that it is a y equals, I need to replace the x with y's and the y's with x. I need to switch their places. And now I'm going to go ahead and I am going to solve for y. So divide both sides by 10. I have x divided by 10 equaling y. But if it's my inverse, it should say g of x. So g of x equals x divided by 10. This is my g of x inverse. Now I'm supposed to graph them. And when I graph them, they're supposed to be graphable across this x equals y line. So graphing this one, the y-intercept is at 0. I'm supposed to go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 over 1. That's only 2 points, so if I can go backwards, 1, 2, 3, 4, 5, 6, 7, 9, 10 over 1, I at least have 3 points to make my line just a little bit straighter. So this right here is my f of x line. The inverse, if I were to fold this paper right along this diagonal, it would land on his inverse. So they should be inverse kind of this direction. I can't graph that. It's not in y equals mx plus b form. So this is supposed to be y equals 1 divided by 10 connected to the x. This is y equals mx plus b form. The y-intercept was 0. I'm supposed to go up 1 over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I need one more, so I'm going to go backwards. So down 1 over 10. Connecting these, I have my inverse. And how can I guarantee they're actually my inverse? It looks like they switch places. So here's f. If I fold this paper along the line, they're just as far away from the line as they are on the other side. If you were to fold it, they would land right on top of each other. That's how you know they're inverses. Our last problem. I am given f of x to be a -1/5 x minus 7. I need to replace the f of x with y so that I could then switch my x and my y's, and I could solve for y to find my inverse. So I'm going to add 7 to each side, and I'm going to multiply both sides by a -5. So I have -5 times x, which is a -5x, -5 times 7, equaling y. So g of x equals a negative 5x minus 35 is my inverse. I'm now supposed to graph them. So go ahead and graphing them. They're supposed to be reflected across this line right here. So my y-intercept is a negative 7. So 1, 2, 3, 4, 5, 6, 7. I'm supposed to go down 1 over 5. So down 1 over 1, 2, 3, 4, 5. Down 1 over 1, 2, 3, 4, 5. I only have 3 points, so let's give me a couple more. So we're going to go backwards. So instead of down 1 over 5, we're going to go up 1 over 1, 2, 3, 4, 5. Up 1 over 1, 2, 3, 4, 5. So here I have my g of x, or my f of x. This is f of x. Well, I'm supposed to graph my g of x. The g of x y-intercept is way too far down. I can't graph it. So what am I going to do instead? I'm going to use the table rule. So here is my f of x table. I had this x value, which is negative 10. And when I did that, I got 1, 2, 3, 4, 5. It was negative 10, negative 5. The other x value I had was 1, 2, 3, 4, 5, negative 5. 1, 2, 3, 4, 5, 6. So negative 5, negative 6. The next point I have is here. So 1, 2, 3, 4, 5, 6, 7. It was 0, negative 7. This point was 1, 2, 3, 4, 5. He was 5. 1, 2, 3, 4, 5, 6, 7, 8. And our last point was 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. 10, 9. If we wanted our inverse, we are just supposed to switch the x and the y's. So what used to be x is now my y's. And what used to be my y's are now my x's. And those are the points we're going to graph. So I need 5, negative 10. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I need, that was supposed to be a negative 5, so that point actually didn't work. That was a negative 5. So negative 5. 1, 2, 3, 4, 5, negative 10. So all the way down to negative 10. Negative 6, negative 5. 1, 2, 3, 4, 5. Negative 7, 0. Negative 7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 0. Oh, that was a negative 8, and that was a negative 9. So these should be negatives. There we go. Because I missed those points there. They were downs. Okay, so negative 8. So here's a negative 8, and I'm supposed to go up 5. 1, 2, 3, 4, 5. And here's my negative 9, and I'm supposed to go to 10, which is right here. So here is my g of x graphed using the table because I couldn't graph this. Now, am I right? Here's the reflection line. These look to be same distance apart, same distance apart. These are the same distance, these are the same distance from the middle line because we used the graph.